Hello, welcome to Math with Beth, and we are going to use second derivatives today to classify max and min values and to sketch a graph. So if you have not already seen the video I did using first derivatives to do this, you might want to watch that one first, because this is now another way to do some of the same stuff plus a way to add to it. So first, the test for concavity. So concavity means, does the graph open up like this or open down like this? So this is concave up and this is concave down. So if you do the second derivative test and you find out that the second derivative is positive for a certain interval, that is when it is going to be concave up. If the second derivative is negative for a certain interval, that is where it is going to be concave down. So if you think about that, if you have a critical point, and in my other video, we talked about critical values and how that is where relative min and maxes come from. So if you know you have a critical value and you test it in the second derivative and it says it's concave down, doesn't that have to mean a max? And if it is concave up and you have a critical value, wouldn't that have to be a min? So the second derivative test is just another way to find out if it's a max and min. But more than that, we can also use it to find where we are concave up, concave down, or where it switches. The point where something switches from concave down to concave up, or vice versa, is called the inflection point. So the second derivative also helps us find that point where it switches from one to the other. So let's do an example so you can see how it's done. So if I wanted to find extrema from this and I wanted to use the second derivative test, I would first need my first derivative. And I would need my second derivative eventually. So I'm just going to find both of them before I get started. And we're going to need to know our critical values. So I'm going to take my first derivative and set it equal to 0 and solve. So first I can take out a 3. And then I could factor a little more by breaking up the trinomial, finding two numbers that multiply to -3, but add to +2. And now I can set each factor equal to 0. 3 equaling 0 makes no sense. If this equals 0, I would get -3 as my solution, and here I would get 1. So my critical points are -3 and 1. So one way to find out if those are max or mins is to plug something here, and something here all into the first derivative to see where it's increasing or decreasing. But another way is to plug the critical points into the second derivative and see what's happening. So if I were to plug -3 into my second derivative, I would get -18 plus 6, which is -12. So that means at -3, we are concave down. So that tells me the -3 must be a relative max. And if I plug in +1, I would get 6 plus 6, which is 12. So it must be concave up there, which means that is a relative min. So this is just another way to do the max and min. But now we can also find out stuff about the concavity by finding the critical value of the second derivative. So plugging in 0 for y for the second derivative and solving, I would get -1. So that means -1 is possibly a point of inflection. It's not going to be a max or min because it didn't show up over here, but it could be the place where we switch from concave up to concave down. So let's find out. I'm going to plug in a number to the left of -1 into my second derivative and see what I get. So if I plug in -2, I would get -12 plus 6. So that would be negative. So it's concave down over here. And then if I plug something to the right, like 0, I would get 0 plus 6. So positive. So I know it is concave down to the left of -1 and concave up to the right. So at -1, it is a point of inflection. So I'm going to find out a little more. I'm going to plug -3 into the original equation to get the rest of that point. And same thing with +1. And I'm also going to do the same thing with -1 so I know what's going on there. So -1 would give me -1 plus 3 plus 9 minus 13. So -2. So if I wanted to sketch a graph of all this, I don't have a lot of room here, but I would first graph all of these points. So -3, 14, we'll just call it there. 1, -18 would be somewhere further down than that, but we'll just call it that. And then -1, -2. So to the left of -3, we didn't find out if we were going up or down. So I'm also going to plug in one of each of these into the first derivative to see if I'm increasing or decreasing. So plugging in -4 would give me a positive. Plugging in 0 would give me a negative, and that makes sense because we knew that this should be a max, so it should be going up and then down. And plugging in something like 2 would also give me a positive. So I should be going up to here. Then I should be going down all the way to 1, but I got to be careful because I got to switch my concavity here. So at this point, I should switch from being concave down to concave up. So it's just a slight switch, and then we should be going up from there. Okay, so we're going to do that again, and we're going to do it this time a little more organized. So we're going to do step by step in the recommendation on how you should be going about trying to sketch these graphs. So first, they recommend find any derivatives and the domain. So just like I did last time, I'm going to go ahead and find my first and second derivative so I can use them for anything I need to later. There's my first derivative. And here's my second derivative. And the domain of the original function, since this is just a normal polynomial, the domain is all real numbers. So B, critical values of f. So I'm going to set my first derivative and my second derivative equal to 0 to find any critical values. So here, I end up getting the square root of 1, which is 1 or -1 in this case. And over here, I'm just going to get 0. So now if they want me to talk about where it's increasing and decreasing, that's all about the first derivative and the first derivative critical points. So I'm going to put the -1 and the 1 on a number line. And I'm going to test each section into the first derivative to see if it's positive, which means increasing, or negative, which means decreasing. So plugging -2 into here, and I do this part quickly because I just don't want you to sit here for 5 minutes while I do this, but just pause and check with your calculator if you're not sure where I'm getting these. So when I plug in -2 here, hopefully you know you're squaring that -2 first. So that gives me +4 times 3 is 12, minus 3 is 9, so that's positive. That's what I'm doing. I'm just doing it quickly so that I can show you everything and you don't get bored. Plugging something in the middle, I'm going to pick 0. So plugging 0 into here makes that all 0 minus 3, so negative. And plugging in 2 gives me again 12 minus 3, which is 9, so positive. So this is a max and this is a min. And I'm going to go ahead and find the rest of the points while I'm here. So I'm plugging the -1 and the 1 back into the original equation to get the rest of the point. So plugging -1 in, I'm going to get 4. Plugging +1 in, I'm going to get 0. Okay, now for inflection points. Now I care about the second derivative, and the critical value I got when I set the second derivative equal to 0, which was just 0. And I'm going to plug in a point to the left and a point to the right into the second derivative to see if it is concave up or concave down. So plugging in -1 would give me a negative. So it is concave down here. And plugging in +1 back up here to the second derivative would give me a positive. So concave down, concave up. This is an inflection point. And I'm going to plug 0 into the original equation to see what the y value would be, 2. And concavity I just did. So I've already done this. So it is concave down from -infinity to 0, and it's concave up from 0 to infinity. That's what I just found out here. So now let's use all of that information to sketch the graph. So first, some important points are these: the -1, 4, and 1, 0. But we also have an inflection point at 0, 2. And we know we are increasing until -1, then decreasing till 1, then increasing again. So this is similar to the one we just did where we're increasing, decreasing, still decreasing, but changing the concavity, and then increasing. So do you see how it's concave down until here, and then it switches to concave up? So that is how you would use the first and second derivatives to find all of this information and sketch the graph. If you have any questions about any of that, or if I went too fast and you need to see another example, please just add a comment and let me know. Thank you.